Okay, I want to do I want to first make two announcements. You probably received already about a few minutes ago is a sign up link for Doodle. So I list a bunch of slots. That's just for tomorrow because I blocked the whole time. Tomorrow I don't have to go anywhere, so I can meet a lot of student half an hour, half an hour. So I put the sign up link there. If you have time or any available, each of the slot can hold at most 4 people, 4 students. But if none of those work for you or you just happen to have a conflict, no worry. Next week I will have a more of such slots. Okay, so it's fine. That's number one announcement. Number two announcement, which will affect today's class. So I have to say at the beginning. I will have a board meeting. That's a very important organization at NCKU, which I am the board member. I have to attend the meeting from 11 to 12. So what I will do is that I will finish the lecture by 11. I will leave. You guys can leave in the afternoon when I come back, and I realize where I stopped at 11 o'clock, then I will continue to record another 1 hour session and I will send the YouTube link to everybody. Okay, so that's the administrative announcement. Okay, so this is what I hope today we can done with homework too, which is I feel this is a really important homework for you to really know how to write a C++ program, not just syntactically, but in terms of learning the principle about object-oriented design, which is quite different from the traditional, what we call procedural programming. So we use this example on top, which is a description about what is the story that we would like to write a program to represent or handle. And then what I did is the step one. So this is the step. We have 3 different steps in order to really fulfill the whole cycle about object-oriented programming. The first started with object. By the way, to do object-oriented programming, depending on how well you are in terms of whether you're a beginner or you're an experienced programmer, you might choose somewhat different paths to do your object-oriented design. But here is a way I suggest to you. I usually suggest this even for the most experienced programmer. So you started with object. You don't start it with a class. You started with object to realize exactly what data or how do I represent the object in terms of the data. Until today, the best representation to fulfill this particular step, in my opinion, is JSON, JavaScript object notation. That's why you see me doing this part. I'm using JSON to represent timestamp. And then I decide to use a person object. So I kind of developed this idea. Not I developed, you guys suggested, I follow. I want to clarify, I want to give you guys credit for helping this process. And we have the concept called traceable person. Okay, called traceable person. And then we basically leverage inheritance construct in C++. So we kind of started with a person, and we also use the other class called personal time GPS record. And also there's another existing class called time location. So you can see that in fact, I don't know whether you realize that about 2 or 3 classes ago, we actually collaborate as a team because you guys has a great idea. And I have experience, I know what G++, C++ class are available. So based on your idea, we work together as a team. Then we can come up with quickly as a class we call it traceable person. Okay, by the way, that is a very important spirit about object-oriented programming. We have some idea what we want to do, but you don't develop everything from scratch. You try to use existing classes as much as possible, because that's going to be shortening the software development cycle. Okay, in terms of software development, this is the principle. You guys are electrical engineering major. You might not have the chance to take a course called software engineering. So I want to tell you there's a few things very important. There's basically two software development model. One is called waterfall. Waterfall means that you design, you understand the requirement perfectly. You design perfectly, and you implement perfectly, and then you testing your code perfectly. And then you basically release the code. That's called waterfall. You follow from requirement analysis, design, coding, testing, and then finally you can release. That's called waterfall. It's clearly that you're in the testing team, you're in the design team, you're in the coding team. Okay, that's very old style. It still works, but it's a very old style of software development. The newer one is called prototyping. Prototyping means that I go fast. I actually don't even know what's required. Okay, remember what I said, waterfall. The first one is requirement analysis. You need to know what's required. So your customer come to you, your customer maybe Google or Facebook come to you saying that, hey, you need to implement this. And so you say, okay, I'm clear about the requirement like a contract. So I did the development. But object-oriented programming enabled the other path. It's called prototyping. Prototyping means that I don't even know what's my requirement. My customer kind of say, hey, I might like this, but I'm not sure exactly that's what I like. You can imagine when you want to develop the realistic system, you want to have this kind of agility or flexibility to be able to change your goal, change your requirement when you see the product. When you see, okay, the car was designed, looks like this. I want to change this a little bit. That's actually better than I thought earlier. So that's why you want to develop something really quick. Get it running such that you can actually start think about, oh, wait a minute. The people who see the outcome and decide, this is not exactly what I want. Then I go back. So go back means you revise your inheritance relationship or doing some changes. So you're kind of doing requirement analysis, design, coding, testing in a way that you have a very short cycle. You want to finish this like in an hour. Okay, usually when I deal with some of the problem, as long as this problem is not hugely complicated, as long as this problem is something I have dealt with before, is that my phone? I want to just make sure no disturb. Okay, no disturb. Sorry about that. So you want to go as fast as possible. Usually, my experience when I want to implement a system that I have similar experience, usually I can create a demonstrable prototype within 2 hours. Usually, because I'm very experienced and I know a lot of classes I can use. So I basically my mindset, people tell me like this kind of things, I can spend within 2 hours to actually get it done. Because I know what classes are available. You guys are telling me an idea, I can actually quickly convert that into a demonstrable prototype. So a prototyping is something you can run, and then sometimes you can show, and then you will see what's right or what's wrong about the original idea. Okay, so that's kind of spirit about the prototyping, or sometimes using object-oriented programming as a tool. Okay, so what we did is we designed a traceable person. The difference between a normal person, the original one we're inheriting from, and the new class called traceable person is that we have an array of time location pair. Okay, time location pair. And that's why we inherit, we're not inheriting time location. We're using this as a containment. We're using this time location class to be one of the components. But regardless, we're doing inheritance or containment, we have to represent the object, because represent the object is giving us a clear information about what information is needed in order for us to do that. Because ultimately, when we solve the problem, the information is important as step one. Step two, we need to worry about how to utilize the information to do something. But step one is try to identify the information. Okay, so time location, we have time. And the location, as you see that under here, we have a location. In our design, we use a different class we call label GPS. So you probably know we have two classes. One, let me actually pull it out. Last time I didn't show you this slides. I have way too many slides. Sometimes I just don't know where they are whenever I need it. Okay. Let me make a bigger. Okay, so this is called the inheritance hierarchy. So I have a class called GPSDD, which is declared under GPS.h or GPS.cpp. And then I have the other class called label GPS, which inheriting from GPSDD. And the difference is that in GPSDD, I have two attributes, longitude and latitude. In the label GPS, I have only one extra label called label, which is help me to decide whether this E building, whether this is McDonald's or this is a Starbucks coffee. Okay, so you can see that this is an inheritance relationship between these two. So what I want to tell you is the time location class is actually using GPS. However, in our JSON representation, I was using label GPS. So there's a little bit difference between exactly the class I want to contain versus, or I want to use, in this case, is time, location, or personalized, personal time GPS record. And inside both classes, they're using GPSDD. But in my JSON representation, I'm using label GPS. So toward the end of the last class, I was saying that, okay, I have two choices. One choice is that, okay, I have to give up my design such that I don't use label GPS at all. I'm just always use GPSDD. So if I use GPSDD, which means that I have to find other places to fulfill the requirement of label, because I feel label is important. You want to know this is electrical engineering department, that is NCKU hospital, that is McDonald's at Daxue Road. Okay, so sometimes I have this information, I have to find a way to fit in. So number one is that I decide in my design, I'm not using label GPS, I'm still using GPSDD, I have to do something else. Okay, that's number one. Number two, what I can do is that, okay, I can modify the existing code. I modify what? I modify time location. Remember I said class time location? Let me actually pull it out. Let me pull it out here. If you remember, this is the time location. Inside the time location, I'm using GPSDD. Okay, I'm not using label GPS, I'm using GPSDD. So of course, one way I can do it is modify or create another class called time label GPS. Okay, I can do that. Okay, well, by doing that, I kind of have some issue I need to deal with. This means that I'm actually creating another class. This also means I might have access to the time location .cpp or .h is a source code. I might or might not. Okay, so introduce a new class sometimes is necessary, but sometimes we might have other options to deal with that. So sometimes in programming, in object programming, you always has to consider your options, whether you should modify a piece of code, whether you have the source code or not, I don't know, because a lot of this, like a Microsoft Foundation class, I think they only released the .h file, they didn't release the .cpp file. So you pretty much has to, it's another story. I'm not going to talk about that today about MFC. Okay. But what happened is that right now, assuming we don't want to modify, we don't want to modify this code. I still want to use this code, GPSDD location and JV time. And then I want to still building a system about traceable person, and I'm using labeled GPS at the traceable person. So how do I accomplish that? Okay, so then I'm going to discuss a very important tool in C++. By the way, this is a very hard topic, and a lot of students got confused. A lot of senior programmer got confused as well, because this kind of casting is simpler in C, but much more complicated if you talk about C++. So what is a casting? So first, let me tell you what is a casting syntax, and then I will tell you the meaning, and then we talk about the ugly part about casting. Yeah, where's my code? Wait a minute. Hold on. See, I have way too many windows. Wait a minute. Is this one? No, not this one. Yeah, I saw I got it right before the class today. That is not good. Is this here? Hold on. Here. So first I want to tell you a casting, what a casting looks like syntactically. Casting. Okay, let me show you this piece of code here. Okay, so I create in this code, let's take a look at this line. This line means that I declare an object called LG1, LG1. And this is a bracket initialization. So I create an object of label GPS. So what is the data type for LG1 is labeled GPS. Now we look at the casting. This is the casting. This is the casting. So in front of the LG1, when I use the variable, I put a different type, GPSDD. I put another data, meaning that if this is called a LG1, and I somehow casting another data type such that it looks like this. Okay, it's two different types, assuming this is GPSDD, this is a label GPS. So when I first present to you, this is LG1. But after I casting, it looks like it's a GPSDD. So I kind of convert from a data type to a different data type. Okay, so essentially that's the syntax. Let me show you another syntax. And I can do this as well. Sorry. And I have another object called GPSDD, which is the gcopy. What's the data type of gcopy? Gcopy, the data type is GPSDD. It's original GPS. Only two arguments, two attributes without the label. And look at what I did here. I actually casting it with label GPS. So I can do from label GPS casting into GPS. But I can also take a GPS casting into label GPS. Okay, I can do this. So syntactic, that's just a syntax. What's the meaning? I'm going to tell you, but now you realize that the syntax about casting is that I can put a data type in front of the other such that the compiler will treat the whole thing as a new type of the object. So the future interaction with the object will relate it to the new data type. That's called casting. Okay, casting is a very important concept in C and C++. I will tell you that why is particularly complicated and important in C++. Okay, so let's actually take a look at this slide about is this the size I want? No, probably not. I want this slide. Yeah, I want this slide to come back. Okay. So now I want to show you a picture. Maybe I can show this picture, the next page. How do I get to the next page? This page. Okay, I'm using this page to just actually tell you a more interesting inheritance hierarchy. So I have a 3 GPS class. The top is on the root of the grandparent is called GPSDD. And then the first level child is called label GPS. And the second level child is called shadow GPS. So shadow GPS inherit from label GPS. Label GPS inherit from GPSDD. They're both two inheritance. They're both doing what we call single inheritance. So multiple inheritance means you have a more than one base class in the inheritance relationship. Okay, but this is all single inheritance. So what do I mean by casting? Casting means that I will be able to, if you have an object belong to one of the 3 types, you will be able to casting that object such that this object looks like the other one in the same inheritance hierarchy. I mean, in general, casting in general, casting can be any 2 data type. For example, I can potentially cast a GPS object to an integer. Integer is a type, by the way. You can actually do that. Sometimes works, sometimes doesn't work. Okay, I will tell you that. That's make life so complicated. Casting essentially you can cast any type to any type, but the compiler sometimes will complain, saying that hey, this conversion they don't know how to handle. Some of the conversion I can help you, but some of the conversion I cannot. But within inheritance hierarchy, it has the information because compiler will know each of the class, and the compiler knows how to convert from one to the other. Okay, they can do conversion from one to the other. Okay, so that's the GPS. Sorry, that's the GPS DD example about okay how you might do casting. So let me repeat what I said so far. So if you have an object that's a GPS DD, you can casting it such that it looks like 2 other piece of code as a label GPS. And sometimes you want to do that. And similarly, if you have a label GPS, and you can actually convert it to GPS DD as well. So now let's go back to the traceable person. So I'm going to use timed location class, which they require GPS DD. But in the traceable person, I really want is a label GPS, right? My application, I want label GPS, and what they provide is GPS DD. Guess what? I'm going to use casting. I'm going to use casting the way is when I use GPS DD, I will cast into GPS DD from label GPS. So I can use the existing class, but in the existing class, actually using a GPSDD instead of the original object, which I want to represent, which is the label. Okay, you can do this, right? Okay, so now assuming you want to retrieve a particular location with the label, then you actually go to time location, you retrieve an object, but I'm sorry, inside the time location, everything is GPSDD. You no longer have the access to the label. Guess what you can do? You can actually casting it to label GPS. You can actually convert it back to label GPS. Then you can actually access the location. Okay, so it's a two-way street. Okay, of course, this two-way street has complication. I'm going to show you. But in principle, if you design the system right, you can actually convert any data type to the other data type within the same inheritance hierarchy, within the same single inheritance hierarchy. And then you can actually then using the class, which is not fit exactly like what you have. Okay, this is a very, very interesting facility that you can do reusability in object design. Okay, so that is just a principle. Now we're going to look at the code to see how you exactly make that happen. Okay. Oh, by the way, there is a third way you can do this. The third way is called virtual function. We're going to go into that in a moment as well. Okay. I haven't released this code. I'm going to release the code after my board meeting. Okay, so this is code I call it EE1520 casting. It only include label. In fact, the first three lines JSON RPC, I actually don't need it. I just need the label. Let me just remove it. I need this. I just forgot to. I don't need this as well. Okay, so let's take a look at the code. So first I create an object called label GPS, LG1, and the constructor has this value. And then I did I can just say there is a function called dump to JSON. I'm going to start talking about the idea about dump to JSON. So dump to JSON is essentially convert object from the C++ representation to a JSON representation. So it's converting from C++ to JSON. So I can just say LG1 call dump to JSON. Or I can do this. I can say I can do a casting from LG1 to GPSDD. I casting and then I call dump to JSON. And then, or I can do the other one, which is even more interesting, is I'm casting as a reference. I'm actually casting from the label GPS to GPSDD reference. So let me very briefly tell you what's the difference between casting this and casting this. When you do casting this, you essentially make a copy of the object, LG1, but only keep the GPSDD portion of the information. But when you're using GPSDD reference, that means LG1 after the casting is referred to the same memory location, the same object instance of LG1. So essentially between this line and this line, they share the same memory. But this one and this one, they actually has two different memory because when you do this, it's actually a copy. This is, you can consider as a copy constructor. This looks like it's a move constructor kind of situation, okay? So you're doing either copy or you're doing reference. That's why the and sign is going to create a very interesting difference. Okay, let's try to just run the piece of code up to this few line and see the result, okay? Okay, I have to move something because I was doing a testing was I think this should work. Okay, so now I compile and then let's try to run the program. Okay, I'm open the two windows so we can see how it looks like. No, I decided not to do this. It's hard to see because the window is too small. Let me just run it here. Okay, so when I run this program down to JSON, I print the JSON. So the original one has 3 because it was a label GPS. So it has latitude, longitude. It also has a label LG1. Okay, so that is the original. If you save it as a copy, then essentially you can see when you do a dump to JSON, you try to see what's that GPS location, and then you got only this 2. Why do you got this 2? Because it got casting into a different class called GPS. And then that GPS only have a 2 attribute. So basically, it says that it's like this. But if you do a casting as a reference, then you still have the 3. Let me actually check one thing. I did one trick before I come to this class. I mean, I want to make sure I doing this correctly. Okay, that's fine. Okay, so now let's actually go back to the code. Just look at the first 2, this few line, this 2 line. So apparently the first line, when you call dump to JSON, is different from the second part. You know what? I want to do one thing, which I don't think it actually compiled correctly. Let me check one thing before I tell you. I want to make a claim because the result doesn't look exactly what I expected. Okay, that's fine. Okay, so by doing casting, I actually get it this way. I can actually get this copy with this. Okay. Right. So now that's actually helping me to convert from a label GPS object called LG1, and I can convert it into a GPS DD format about the LG1, which is another object. And when you call the function dump to JSON, it only have 2 arguments instead of 3 arguments. Okay, before I tell you the how do I implement dump to JSON, because that's another things I want you to learn. I want to tell you the other way. How do I convert it back? So now I'm actually have a 2-way to convert it back. The first way is I take a GPS DD, which is I'm going to make a copy. And I'm trying to say, okay, with this copy, can I convert it back? So this is now started with GPS DD. and now I want to convert it back to label GPS. Okay, this is what I want to do. And if I do this, compile this code, now I'm going to get an error. And you can see that the error message basically say, the error message saying that there is no matching conversion of C style cast from GPS to label GPS. So it basically say, hey, I cannot do that. You want to downcast from a GPS to label GPS, essentially because you already lost the information in the conversion process on the way up. Now you want to go down. You cannot do that. Okay, but there is a way to actually deal with this situation is I have to use reference. So that's why I want to show you different parts of the code. If you add, instead of using this, you do can I do an M here? Let me try. I never tried this, by the way. You see that the second part of the code works perfectly. What I did is I have a M sign when I do this line. So let me show you what's the difference between these two. I want you to compare, spend about 5 seconds, take a look at this piece of code. And this piece of code. What's the difference between these two lines of code? This and this. What's the difference between these two lines of code? Anybody want to volunteer to guess what's the difference between these two? One is copy. This is copy, this is reference, right? What's the meaning about copy and reference? Meaning that when you do this assignment operation, you essentially find another piece of memory that has an object. So essentially, LG1 is in one particular place in your memory box, but Gcopy is the other part. Well, when you do this, LG1 and G reference, they are referring to the same memory location. But you can imagine what happened is that in the memory location that's pointing by LG1 has 3 attributes: label, latitude, longitude. But the thing is that it has, okay, I want to use this slide to tell you what it is. This is quite interesting. This is a complicated life for C++ programmer, not Python programmer. Okay, so I want to show you a picture and so you know why I spend so much time on memory. Do I have this? Yeah, I think I have this. Okay. So I'm actually represent an object. When you create a label GPS object, you have a GPS DD component, which you have also a label GPS component. Okay, you have this component. So most of the case, the memory layout looks like this, which means that the memory, the first part is actually GPS DD, and the second part is label GPS. Normally, that's the case. So when you actually casting by reference, essentially you're still referred to the first portion, but the second portion is still there. But from the compiler perspective, when you want to use the reference, they only see the first part, but when you cast back to label GPS, you will be able to see the whole thing. But the memory is always there. Having said that, I don't mean to make your life more complicated, but when you're using virtual function or virtual inheritance, particularly there is a concept I'm going to tell you called virtual inheritance, you will realize the order of these two objects might flip. Means that the memory, it could be that the label GPS is on the top, GPS DD is on the bottom. Such that when you do the casting, the reference, the pointer might actually shift by the compiler. So the compiler knows whether you're using virtual inheritance or you're using some other feature which causing the memory going to be flipped in the runtime environment. I will tell you about this after we talk about virtual function. At this moment, there's a very good reason for you to understand that. Let me actually show you a picture about why it looks like this. Let me see, do I have this picture here? I remember did I have a slides to talk about this? Not in this set of slides. Okay, unfortunately. Yeah, I will talk about that. That is a great lecture to learn the complication about C++ as a programming language. Okay, so that is for reference. So you're referring to the same location, but in some very complicated case, the pointer might need to be shifted because of the memory arrangement or memory layout about your C++ object. Okay, not worry about that now, but later. But if you try to do casting as a copy, not with an M sign, with a copy, then essentially after you do the casting, you have two different copies. One copy is GPS DD alone and without the label component. And then the other part is the original one. That's why I have the compiler error, because I'm using casting as a copy, and I want to convert it back to this side. And it will complain. By the way, there's still other way I can do this. Even I do this, I can still convert it back. Because you can think about, okay, I just need to add another component after this. There's a way to do that, but I'm not going to tell you how to do that today. Okay, so that's the difference, important difference between casting as a copy and casting as a reference. Okay, so I hope I gave you some idea about how to do how do I use time location class, which needs GPS DD, but I want to keep as a label GPS. And the trick is I have to use casting, and I have to use casting as a reference. If I've done this, then I will be able to reusing that class and then go up and down as I need it. Okay, so that's the first part I want to tell you about casting. I will come back to casting for more complicated case, but I want to tell you a little bit about dump to JSON. I want to tell you how I implement the dump to JSON class. Okay, first, I'm going to modify the code back to the original state. I'm actually declare dump to JSON as a virtual function instead of regular function. Okay, I haven't told you what virtual function is. You don't need to worry about that at this moment. But there is a function called dump to JSON. It takes no argument, and the return is a pointer to a JSON object. It's a pointer to a JSON object, JSON value object. So let me show you how that works. So I have to go. This is under the GPS.cpp, the implementation of the class. And let's take a look at the dump to JSON. Okay, here it is. It's very short. It's not too complicated. So what I did, this is the definition for this JSON. So what I did, you can see that I basically create a JSON object, which is a using new. That means I'm using dynamic memory allocation. That means this particular pointer result PTR is going to be still valid after I exit this function because I want that JSON object to be permanent. So I create, this one is just like constructor, but I'm using malloc style of constructor. Okay, I can do this. Okay, once I do this return result pointer, look at what I did. I do a star result pointer, and then using bracket and says latitude is equal to this to the latitude. So remember what's a JSON is key value pair. So the key is here, and the value is there. And then again, I'm doing a longitude and this to the longitude. Okay, I just need to write this two piece of line. Then I'm actually going to have a JSON object with this two key value pair, latitude and longitude. And then what I did is just return that JSON object. So let me summarize what I did. I create a JSON object. I introduce first key value pair, longitude, second key value pair, latitude, or the other way. And then I return the pointer to the object. And that's dumped to JSON. So I essentially represent the C++ object into a JSON. So that's what dump to JSON is. Okay. Just a small question I want to ask you. When you learn C language, when you do this bracket, right? When you do the bracket, that the index to the bracket is always an integer, right? When you do an array, it's an integer. But now you see I can do a bracket with a string in between. What trick I use here to be able to do this? One of the terms you should learn is called operator overloading. I overload the bracket operator. So it used to be the operator is actually only with string, now it's integer. Okay, and I'm going to stop here and I will continue this afternoon, but you guys can leave now, okay? All right, see you later. I need to run to the other building to attend the meeting.